In this video for Computer Science 9618, we're going to be focusing on the AS level, doing a Paper 2 exam walkthrough. Now, before we get started, there's a lot of carryover from Computer Science 9608 to Computer Science 9618. Now, if you're looking at past exams to prepare, make sure you are looking at 9608 exams as well, since a lot of it carried over to 9618. Now, if you're not familiar with papers or if you're a first-time student, there's some things you need to know. Computer Science 9618 AS will consist of Paper 1 and Paper 2. Computer Science 9618 A-Level consists of Paper 3 and Paper 4. Now, all four papers are added together and used against the grade threshold to determine whether you're an A prime, A, B, C, D, E, or U for your overall grade. Let's take a look at what we need to know for Paper 2, and this is straight from the syllabus. It's a fundamental problem solving and programming skills. Problem solving is probably the most important skill you can have coming into the exam because you have no idea what algorithm they're going to ask you to do. So problem solving is your number one skill that you must come in with. So it says it's worth 75 marks. You have 2 hours. It's going to assess sections 9 to 12 of the syllabus content. That's all the programming portion of the AS level. Candidates will need to write answers in pseudocode. So we do have a pseudocode guide that walks you through pseudocode for Computer Science 9618. If you need to check that out, make sure to do so. It's going to be a written paper, so this isn't done on the computer, and it's externally assessed. That just means you're going to answer all the questions, and you don't have to go anywhere to do it. You just go to the school that's doing it. So it's going to be worth 50% of your AS grade. If you're going to continue in the A level, it'll be worth 25% of the A level exam because they're going to add the 4 papers together. So let's go ahead and dive in and take a look at question 1. All right, so simple algorithms usually consist of input, process, and output. The statements in the following table are in a generic programming language. Complete the table by placing ticks, which are check marks, in the relevant boxes. So this is one way they could evaluate whether you know what input, process, and output is, which is the basic sequence of an algorithm. We take input, we process that data, and we produce an output. That is the basics of computer science. Another way they may ask you is, what are the 3 stages of designing an algorithm? And well, that is input, process, and output. So this one's worth 6 marks. So pretty easy to pick up 6 marks, almost 10% of the total score in the very first question. So we have string 1 equals hello world. So we're looking to see, are these 4 items, are they input, process, and output? So in the first one, we have an equal sign, which means we are assigning a value. So what is that? Is it going to be input, process, or output? Well, we're taking input because what we're doing is we're taking hello world and we're storing it inside string 1. So that's going to be input. There's nothing else happening in this section. Let's take a look at the next one. We have display. Display is a dead giveaway. If it's being displayed to a user, we know right away that must be output. But what about this write string 1, 5? Well, this is string manipulation. What we're doing is we're taking string 1, which is hello world, and we're going 5 spaces from the right and outputting the rest. So that is going to be process. We are processing that string. Look at the next one. We have read file. If you're reading information from a file, you're putting information into the program. Just think about when you're loading a saved video game. When you're loading those saved contents, it's loading onto the computer or the CPU or the RAM so it can actually be used by the program. So that is input. Now, what about write file? Well, if we're writing to a file, we are taking information from the computer and we're writing it externally to a file. So that is output. But notice here we have my file, and then data is, and then we're concatenating that with string 2, whatever that may be. So data is and string 2, because we're writing to the file, we're not just writing a string, we are manipulating that, and because we are adding the data is, so that is process. So you'll notice this is 6 points. There are 6 tick or check marks there. Let's go ahead and move on to the next part. And you'll see this happens a lot, item 1B. So it's not going to go 1, 2, 3, 4. It's going to go item 1 or question 1, and then letter B, item 1. So they're going to be assessing multiple things from various topics. So anyway, let's go ahead and get started. A suitable operand type for an arithmetic operator is blank. A suitable operand type for a logical operator is blank. When you're using an arithmetic operator, plus, minus, multiply, or divide, there are various operand types that you will need. And that could be integer, it could be real, that could be decimal if you're in Java, that would be double, or it could be float. Anything that will hold a number or decimal will work. You don't have to write all of them, you only need to write one of them. And then a suitable operand type for a logical operator, there's only one. That's your and, your or, your not, your XOR, and etc. And those are your Boolean operands. So that's it for that one. Let's go ahead and move on to the next one. So this is what I'm talking about, 1B. 2. The following table shows the values of 3 variables. These are your Boolean operands that you have here. We have and, we have a couple ors, and then we have some not. So we see flag A is true, flag B is false, flag C is true. This is worth 3 points, and if you have done any type of logic circuits or logic gates, this is going to be super, super easy to do, and an easy 3 points that you can get. So here we have flag A and flag B or flag C. So we have T and F or T. What is the rule for an AND Boolean expression? Both of them must be true. So this T and F evaluates to F. So now I have F or T. I have false or true. What is the rule for an OR? As long as at least one is true, it will evaluate to true. Then we take a look at the next one. Here we have T and F or T. So F or T has to be handled first. So when we do false or true, the rule for OR is that at least one of them must be true. So here we see one of them is true. So this is going to evaluate to true. What is true and true? As long as both of them are true, it'll evaluate to true as well. Now when we have not A and flag A and not flag C. I take a look at flag A, it's not true, or flag C is not true. Well, what is not true? That means false. So not T evaluates to false, or the other not T evaluates to false. What is false or false? Neither one of them is true. In order for an OR statement to produce a true, at least one of them has to be true. Because neither one are true, this is going to evaluate to false indeed. Let's go ahead and keep pushing along. And we see here the loop construct, also known as repetition or iteration, appears in many algorithms. Use pseudocode to write a post-condition loop to output all the odd numbers between 100 and 200. When you come to a question and you have to write pseudocode, this is problem solving. You have no idea to prepare or know what they're going to ask. So you got to be ready for all possible problem solving exercises that you have. So here we have a post condition loop. So you say, okay, we're going to do post condition. That means the code's going to run. Then the condition is going to be checked at the ends. And we're outputting all odd numbers between 100 and 200. So they don't want to count control loop, which is a for loop. So I start with num. I'm going to assign that to 101. Because remember in pseudocode, we have the arrow when we're assigning a value. Then I'm going to have repeat. Now my number I'm going to start at 101, and that's because inside I'm going to output num, which will be start me with 101. How do I get to 103, 105, 107, all the way up to 199? I'm simply going to add 2. I'm going to take num, which I have here, and I'm going to assign that to the value num plus 2. Then it is a post-conditional loop, and I do until num is 199. So what will happen is when num gets to 199, it's going to check. When num is 199, it will run again because it says until num is greater than 199. When it loops back around, it's going to output 199, which is the final number we need. We're going to increment it by 2, which gets me into 201. Then it says until num is greater than 199. Because 201 is greater than 199, I exit the loop and nothing is outputted. So an easy way to pick up 4 points there. All right, number 2. So we're done with question 1. Now moving on to number 2. A multi-user computer system maintains a text file containing the ID and preferred name for each user. User IDs are unique. So they're using some primary keys here. Preferred names may be repeated. Stepwise refinement is to be applied to the following 3 steps. After a user logs in, a welcome message is produced as follows. 1. Search for the user ID in the file. 2. Read the preferred name from the file. 3. Output the welcome message. Describe the goal of stepwise refinement. None of this information is needed to answer Number 2, letter A. You do not need any of this information. They're asking you is, do you know what stepwise refinement is? And they're looking, you'll notice it's 2 marks, so they're looking for 2 things here. So stepwise refinement increases the level of detailed design in an algorithm. You're getting into the smallest steps. It's being broken down. You're looking at the extreme detail of what each step does. And once it's broken down into its smallest parts, it is then programmed. You may have seen this when you were covering structure charts in your class. Hopefully you covered them. But this is when we have everything broken down into its smallest part. Say hello is a procedure that does something. Average is a function that does something, and it's breaking it down to its smallest part. So that is what stepwise refinement is. Let's keep pushing along. So part B, an initial identifier table is created as part of the stepwise refinement. The section of the table, then we have it shown below. Now remember, we have a multi-user computer system which maintains a text file containing the ID and preferred name for each user. User IDs are unique. Preferred names may be repeated. So this is the table they have given us here. So they want us to give the data type and the description. Now you can't be very generic with your description. For example, search user ID. You would say stores the user ID entered being the keyword, showing that it's taking input. So here they talk about a text file, so we're going to reference that in our answer. The first thing we need to do, let's just get the data type of these and pick up as many points as possible. So search user ID. It's going to store the user ID that is entered, and that is going to be a string. The file user ID, well, that's going to be the ID found in the file. Well, if we're searching for a user ID and that's a string, that means the file user ID must also be a string. When someone has a preferred name that's made up of alphabetic characters, that is going to be a string. Then we have ID found flag. Now, flag is your dead giveaway that it must be true or false. They call these flags, and it's either going to be flagged as true or false. What does that mean? There's only one data type that can be, and that is a Boolean value. Now, let's talk about file user ID. What is the purpose of that? Well, it stores a user's name loaded from the file. You can't just say it stores a user's name because that's not being specific enough. Up here we said stores a user ID. Stores a user's name, the user's ID, but we say it's loaded from the file. If we just say, hey, it stores the user's ID, that's not going to be enough because search user ID says the same thing. So we say from the file, and it mentions that's text file. File preferred name string, that is inside the file. So it stores a user's preferred name loaded again from the file. Then we have ID found flag. We can't just say it's, it represents true or false. That's not being specific enough. So we have to say if the user ID is found in the file, then ID found flag is true. And if not found in the file, it's going to be flagged as false. So that's how you do this question. Let's go ahead and move on to number 3. A string conversion function, xcaml, needs to be written. This function forms a return string, out string, from a given string, int string, by 1, separating the original words, now a word is assumed to start with a capital letter, converting all characters to lowercase. The following shows a pair of example values for the string values in string and out string. So the in string that's being passed to the function is my user input. When we clean it or output it and run it through the function, everything will be lowercase, and we're going to insert a space between each word. How do we know when a new word starts? Well, if you look closely, you'll see my starts with a capital M. The next word starts with a capital U, and then input starts with a capital I. So that allows us to figure out when a new word starts. Now it says you may assume that in string always starts with a capital letter. The following is a first attempt at writing the pseudocode for this function. Complete the pseudocode using appropriate built-in functions. For the built-in function list, refer to appendix on page 13. A word of advice, do not rely heavily on the appendix. When you walk into your paper 2 exam, you should be ready to start the test and know what you're doing. Now, it's good to reference the appendix just for a quick refresher to make sure you're using it correctly. But if you're not familiar with it and you're going to walk in and say, well, I'll just figure it out when I get there, that is a bad decision. So definitely become familiar with it. So let's go ahead and let's break this down step by step here. So let's go ahead and get started with this function xCamel. When you write your function in code, you're going to be using by val or by ref. Now, if you're in Java, it's always by val. You don't have an option there. But in this one, we're going to simply put in the variable, and we have to declare its data type just like we normally would. So the parameter's in string, and that is simply going to be a string. What is it returning? It's returning out string, which is a string. So we have the parameter and the data type that's going to be returned. Now we have declare next character. So the next character will be declared as a char data type, which stands for character, holds one letter. Then we have declare something as a string, declare in as integer. So there's only one thing left to declare here, and that is out string. So we declare out string, in is declared as integer. Then we have initialized the return string. What does that mean? That means we need to assign a value to out string. So we do that with an open and closed quote. So there it is initialized. So let's go ahead and keep moving on to the next part. So now comes the problem solving. And this is why you want to be so good at problem solving. You can never practice problem solving enough because this whole thing is going to be problem solving. So loop through in string to produce the out string. Okay, we can do that. For in equals 1 to something. Well, from first to last. We have no idea what the in string data is going to be. However, we can use a string manipulation tool or a string tool to determine the length of in string. So we use len, which is from the appendix, which stands for length. What are we getting the length of? The in string. Then we have next char. It wants us to get the next character. Well, that is string manipulation. This is why you want to be familiar with programming and being familiar with string manipulation. We're going to use mid. What string are we working with? In string. Where are we starting? The value of in is where we're starting, and then how many characters we want. Next, we need to check if it's uppercase. You want to be familiar with the ASCII code chart because what we're looking to see is if the next character is greater than or equal to A. Notice there is a capital A, not a lowercase a, big difference there. And we do this with single quotes, and we want to make sure that the next character is less than or equal to a Z, a capital Z. When the computer reads this, it has no idea what an A and a Z is. It doesn't know. All it knows is it's some type of symbol that it's outputting. But what it's comparing is to see if next char is greater than or equal to 65, which is the value of capital A, and less than or equal to 96, which is a capital Z. At 97, the lowercase letters start. At 64, going backwards, the numbers as well as some other symbols start. So it wants to make sure it's between a capital A and a capital Z. And if it is, then we're looking to make sure it's greater than 1. If it's greater than 1, we're simply going to add a space to the out string to separate those words. How do I do that? Output string, what am I loading? I'm loading the pre-existing data and I'm concatenating a space. Make sure Cambridge knows that you have a space there. So if you want to make it a little bigger, you can just to make sure they know that the space is there. So that's going to close this if statement. So we're looking to see if the next character is greater than or equal to A, less than or equal to Z. If in is not greater than 1, then we need to make the next character lowercase. And we do that with next char. How do I make something lowercase? Using that appendix and being familiar with code, we know that is L case. What are we lowercasing? The next character, storing that into the next character. Then we add next character to the out string. Not a problem. We're simply going to update string with a concatenation of the next char. So out string, we're going to take out string, the pre-existing data there, and then what we're going to do is we're going to concatenate that next letter on there. That's going to end our for loop, and then we simply return because functions have a return statement. What are we returning? We are returning out string. So that's going to be it for number 3. Let's go ahead and let's take a look at the next one. Okay, high-level programming languages have many features that support the modular approach. One such feature is the use of parameters. State 2 other features. Well, there's lots of things that high-level programming languages do. The modular approach means you can create custom modules or custom procedures or functions. And one such feature is the use of parameters. So we can't use that, but we can use procedures, and we can use the other, which is functions. Now, another option you could have, they're only asking for 2. You do not write more than what is required. You don't have to explain what procedures and functions are. It just says state 2 of them. But another option you could have talked about is variables. Now, You can't just write variables, you have to be specific because there are two types of variables. There are both local variables and there are global variables. Let's go ahead and let's keep moving on. So for B, procedure, my procedure X is going to be a parameter here. Then they're assigning X as X plus 1. They're ending the procedure. Then we have some intermediate lines of pseudocode not shown. So further down somewhere else outside this procedure, somewhere else, we're going to assign the value of 4 to X. Then they're simply going to call my procedure X, which is this one right up here. They're going to pass X. They're calling my procedure and passing X, and then they output X. So it says is used to pass data to procedure, my procedure, which we just said. There are two parameter passing methods that could be used. And I made reference to this in the previous question. Complete the following table for each of the two methods. Well, the first one is the one that is most commonly used, and that is by value. Now in VB, that is done BYVAL, no space. It simply stands for by value. If we pass a copy of X, which is 4 up here, X is 4 plus 1, which is 5. Then if we output it, because it makes a copy, the output value is still going to be 4. And that is because the original value of X does not change. The value of X is simply copied when the procedure is called. Now, if we had the output up here in this procedure, it would be 5. But once we return, X has not been changed. The copy of X has been changed, but we're not calling the copy of X. It just copied that value. If we wanted to change, that brings us to by reference. By reference, the value would be 5, and that's because the original value of X does change. It is the address of X, not the data, but the address of where X is stored on the RAM that is passed when the procedure is called. Because the address is passed, we're saying, okay, at that address, we want to overwrite whatever the value of X is plus 1. Because it's overwriting where it's stored at that address, that is why the value changes to 5. And that is the difference between by value and by reference. So let's go ahead and move to the next question. A multi-user computer system records user login data. Each time a user successfully logs into the system, it records the following data. So they give us 3 data items and some example data. Let's go ahead and preview the question so we know what we're looking for. The data items are concatenated, joined, using a separator character to form a single string. So it looks like they're going to combine user ID, port ID, time and date into a single string. I don't know why nobody would do that, I don't think, hopefully not. That would be a lot of work to extract that data. But it doesn't matter, we're not writing the questions. Our job is to problem solve and answer the question. Each string represents 1 log entry. Suggest a suitable separator character. Okay, so that's what they want us to do using that separator character. They want us to figure it out. Okay, not a problem. User ID. So we have Jim and 27. So automatically that gets rid of any alphabetic characters. We cannot use those because we have no idea what their name is going to be. It could consist of any letter, so we can't use letters. And we have 27. Can't use numbers. Those are out the door right away. Port ID, once again, we have numbers, nothing new there. So we know we can't use alphabetic characters. We cannot use numbers. Then we have time and date. All right, 8:30, June 1st, 2015, 8:30. Notice we have something new. We have a colon. We can't use a colon either. We still have letters and numbers. Do not overlook these spaces. Spaces can also not be used because they're going to separate time and date that way. So we can select anything as long as it doesn't appear in the example data. I chose a % sign because that does not appear. And I let Cambridge know that I chose a % character because it does not appear in any of the example data, therefore it can be used as a separator character. So I could have chosen the exclamation mark, which doesn't appear, the @ sign, the pound or hashtag, the money symbol, the caret symbol, the ampersand, the asterisk, or even the parentheses, the underscore if I wanted to, but I just chose the % sign. Any character you can use as long as it doesn't appear in the example data. So let's keep moving along. So on this one, use pseudocode to declare log array. Well, the concatenated strings are stored in an array called log array, which may contain up to 20 log entries. So When we declare log array, we do that by using the word declare. The name log array, we declare it as an array with a lower bound and upper bound, and it's going to be a string because it says concatenated string. So here's how we do that. We declare the name log array. That is going to be an array. We declare the lower bound, the upper bound. So lower bound 1, upper bound 20. We put that in brackets of string. Just so you know, it does matter whether these are brackets or parentheses. I do know for a fact that if you use parentheses, it will be counted wrong. So make sure you are using brackets. So let's go ahead and take a look at another problem-solving question. So this is part B here. It says 5A2, but it's 5B. A procedure log events is required to add the log entry data from log array to the existing text file loginfile.txt. Unused array elements are assigned the value 4 asterisks. These can occur anywhere in the array and should not be written to the file. Write program code for the procedure log events. Then it gives us some information about VB and Pascal. Now, just so you know, because this is a 9618 video, paper 2 is not only pseudocode, so we're actually going to write pseudocode for this example. Even though it says write program code, we can still write pseudocode and work out this example. So that's what we're going to do, is we're going to use pseudocode here. What we get started with is writing the procedure headers. So the procedure is called log events. That was given to me right here, write program code for the procedure log events. Now, in the 9618 pseudocode guide, we do not use parentheses when we're writing our procedure log events. We use parentheses when there's a parameter. There's no parameter being accepted here, so we don't need the parentheses. The next thing I need to do is start thinking about some variables that I may need. Well, I'm going to need data. That's going to hold information from the log array. Then I'm going to need index because I'm going to need to be able to progress through the array. So I do that with index. You can use I, you can use N, you can use X, you can use whatever you want. I think it's a good idea to use index so you show Cambridge that you know what you're doing. Data or any other type of name to represent holding the data would be fine. And then I want to open the file, loginfile.txt, that was given to me, but I have to decide why I want to open it. And when you open a file, there are 3 things you can do with it. You can write, you can read, and you can append. So writing to a file is obviously writing new contents to a file, overwriting the old ones. Reading is taking input from the file. And then append means we're going to update the file. This means keeping the old contents while writing new contents to the file. Because we don't want to delete the old contents, and we want to add to it, we're going to open it for append. So that would be the first section, the first thing you need to handle. The next thing you need to do is you need to go through the entire log array. So we do for index, which is 1 to 20, just using a for loop here. If log array index, if it's not equal to 4 asterisks, then I know I have some data that I need to write to the file. So inside data, I'm going to store whatever the log array index is, whatever's there, I'm going to store that into data. Now this takes up a lot of lines here because we have then, which is indented and does go on to the next line, and that is in the pseudocode video if you need to take a look at how pseudocode works. If it's not equal to the asterisk, then I'm going to write to the file, loginfile.txt, put a comma. What am I adding to that file? What am I writing to it? I'm writing data. There's no such thing called append file. When you open it for append, it is understood that when you write to the file, you're not overwriting the old contents, you're keeping the old contents and simply adding the new contents. Then that's it for that. So I'm going to end my if, and then I use next index. Now, earlier in the video, you saw end 4 was printed. In the new pseudocode for 9618, it is not end 4 anymore. And it used to be one word. There is no space there for a reason. It is next, but then you put whatever the counter was. So because we used for index, we used next index, which tells us we are done at the end of the for loop using index. And that's helpful when you have nested for loops that show up. Then we're going to close the file. That's all we do. And there's one last thing we need to do, is we need to end the procedure. And yes, it is one word just like that. Let's go ahead and move on to the next question. Moving on to this last question, a computerized vehicle licensing system stores details about vehicles and their registration marks, which are number plates or license plates. They give us some rules that it must comply with. Has to be between 6 and 9 characters long. All right, we can do that. Characters 1 to 3 are uppercase alphabetic characters. We can check for that, not a problem. We did it earlier. Characters 4 to 5 are numeric characters. We can check and make sure characters 4 and 5 are numbers. Remaining characters are uppercase alphabetic. Well, we can do that. It's the same as the second rule, except for it's the remaining characters. All right, a function validate registration is needed to check that a given registration mark follows these rules. This function takes a string registration as a parameter, so we need to know that. Returns a Boolean value, we also need to know that. So we have enough information to write our function header. Tells us true if it's a valid registration, false otherwise. Well, that's a good choice. I don't know what else it would be. Write program code to implement the new function validate registration. Because this is Computer Science 9618, we are going to be writing pseudocode. Now, I will be doing a full paper 2 9618 walkthrough. But remember, earlier I said 9608, a lot of it carried over to 9618, and you can problem solve this. Just because it says write program code doesn't mean you have to. You can write pseudocode. So this is a good one. I like this one a lot. So let's go ahead. Let's take a look at this paper and let's go ahead and let's start writing our function. And the first thing we need to do is write our function header. Well, it's called validate registration. I said it was going to take registration as a parameter. Because it's taking registration as a parameter, I must declare the data type. How do I do that in pseudocode? I write the name registration, my colon, and then as a string, and it returns a Boolean value. So I need to have a variable that's going to keep count of how many upper characters or uppercase letters there are, because the first 3 must be uppercase. Then I declare num chars. I need to know how many characters it is. Is it between 6 and 9? So that's going to be integer. And I need to know that I have the right number of characters. Then I need the current character, because I'm going to need to use string manipulation to isolate each character. I need to check and make sure that the first 3 are uppercase, the next 2 are lowercase, and the remaining characters are uppercase as well. Because I'm using string manipulation, I'm going to be using a for loop that goes through each letter of the word. So I'm going to need index, and then of course I'm going to need the variable that I'm returning, which is called valid, which is the Boolean value. Now that I have all that, I think we're ready to start writing the function. So we start with valid set to true, and the reason for that is because it's easier to set it to true and change it to false rather than changing it from false to true back to false. It's easy to oversee that because there are multiple rules it must follow. So let's go ahead and get started. These are the rules right here. So it must be between 6 and 9 characters long. So if the length of registration is less than 6 or it's greater than 9, that automatically breaks the first rule. Valid becomes false. If it's not less than 6 and it's not greater than 9, then what I can do is I can run my for loop. And I'm using 1 to 3 because characters 1 to 3 are uppercase alphabetic characters. Well, the current character, I'm going to use string manipulation. I'm using mid. I'm working with the registration string. Where am I starting? I'm starting at index. How many letters do I want from there, or how many characters? I want 1. I'm going to put that into current character. Now, once I have something stored in current character, I need to make sure that those are alphabetic characters. So if it's less than A and greater than Z, it must not be an uppercase character. So valid becomes false, and if next index. So that right there checks for the first 3 characters. Now, listen, I'm still inside this original if statement. This one's in red. It does not close until you see an end if in red. So the next set of code I'm going to write is still inside this if statement. So it looks like the first rule, if it passes the first one and it's still true because we set valid to true, we're going to check for the next one. So we're looking for characters 4 to 5 are numeric characters. Well, I don't need to start at the beginning of the word. Simply start at character 4 and 5. Current character. This time I'm going to be using mid just like I did last time, starting at index pulling 1 character, but this time the index is going to start at 4 and it's going to end at 5. Now, it says it must be numeric characters. Well, if it's less than 0 and greater than 9, it's not a numeric character. Those are the only numeric characters there can be. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if it's not there, well, valid becomes false. We end our if, we close our loop. We need one more to make sure the remaining characters are uppercase alphabetic. Now, it says 6 to 9 characters long. Well, if I run my for loop to 9 and it's not 9, it's going to crash. Well, we problem solve. Is there something else we can run our for loop to the end of the word? And yes, we can. For 6, to length of registration. I store the current character. I do it the same way I've been doing. I'm going to use my string manipulation mid. I put the string I'm working with, which is registration, where I'm starting the index, how many characters I want. Then I make sure that the remaining characters are uppercase alphabetic. So I run code that I've already used. If current character A is less than A, current character is greater than Z, I know it's not an uppercase letter, so valid becomes false. And if I close my loop, next index, and if this closes the first if statement, which was also in red at the beginning, and then what I need to do is I need to return valid and then end my function. And just like that, probably the hardest problem on this test is solved, and this one's worth 11 marks. So even if you don't get all of it, and you should be able to get all of it, simply by breaking it down into sections and problem solving, you should be able to get the majority of the points here. So let's take a look at the very last set of questions that also relate to number 6. All right, for the last one, 6b, the function is to be tested. Give a valid string that could be used to check that the function returns true, which means we have to come up with a string that conforms to the 4 rules that we should be very familiar with after writing that function. So I chose capital E, capital C, capital S, 85, capital C, capital C, capital S. Must be between 6 and 9 characters long. 1, 2, 3, 4, 5, 6, 7, 8. Conforms to the first rule. Characters 1 to 3 are uppercase. 1, 2, 3. Those are uppercase letters. Characters 4 and 5 are numeric. 85. Those are numeric. Remaining characters are uppercase, and they are. So that one returns true. Now moving on, it says modify your valid string 1 to test each rule separately. So we need some strings here that will test each rule. So in the first one, this is what I chose. And this checks the first rule. It must be between 6 and 9 characters long. So this is testing to make sure that the length of the parameter in the program is between 6 and 9 characters long. This example breaks the string rule, which allows us to make sure the code works as intended. We tested for true, so now what we have to do is break each of these rules and test and make sure it comes out as false. But we need test data to do that, and we have to come up with test data. And that's what they're assessing here is, can we come up with test data to test our program? So the next one, ECS8CCS. Well, I'm checking the third rule. Characters 4 to 5 are numeric characters. This is testing to make sure that the 4th and 5th character of the parameter in the program is 2 digits. This example breaks this rule, which allows us to make sure the code works as intended. Then we have 2 more that we need to do. So here I did E85CCS, going back, testing rule 2. This is testing to make sure that at the start, there's the correct number of capital letters. And then what I need to do is I need to, I can break the last rule. Remaining characters are uppercase alphabetic. I can also test for something that didn't show up in the rules, but that should be implied. Only alphabetic and numeric characters are used. There are no special characters. So if I throw in an exclamation mark, that should come out as false as well, because that's never used. So this is testing to make sure that only alphanumeric characters are used and no special characters. I hope you guys found this video helpful. If you did, make sure to give it a thumbs up and subscribe to help the channel grow. There are more videos on the way, and there's also full paper walkthroughs on the way as well. We'll see you guys in the next video.